Buenos días, buenas tardes más bien, ya pasan de las 12. Miren, es un gusto para mí, para el Departamento de Computación, tener como invitado aquí a Miguel Ángel Sánchez Pérez. Él viene de Oracle, el campus que tiene Oracle, bueno, sí es un campus que tiene ahí en Zapopan, por el lado a Guadalajara, en Jalisco. Nos va a platicar sobre este trabajo que desarrolla él en Oracle, que tiene mucho de investigación. Miguel es egresado el doctorado en julio de 2018 aquí en el Centro de Investigación en Computación del Politécnico. Hizo la maestría también allí, hizo la licenciatura en la Escuela Superior de Cómputo del Politécnico, siempre con las mejores notas, o sea, es de los chicos estrella de su generación. Y bueno, pues ella es Dulce, ella es reclutadora de Oracle, o sea que si ustedes tienen interés en seguir un desarrollo parecido al que tiene Miguel, que yo lo encuentro sumamente valioso, o sea que es ver cómo egresados de centros de investigación del mejor nivel en México pueden desarrollarse de una manera profesional muy plena en la industria, ¿no? O sea, fortalecer ese vínculo academia-empresa, industria y del mejor nivel a nivel mundial. Creo que es una cosa muy valiosa y en ese sentido tener aquí a Miguel tiene ese enorme valor. Y bueno, pues a los interesados aquí está con quien dirigirse, ¿de acuerdo? Pues un aplauso para Miguel.
Bueno, voy a cambiar a inglés porque es un requisito de Oracle y a veces es más fácil explicar algunas partes, algunos detalles técnicos relacionados. So, I'm Dr. Miguel Ángel Sánchez Pérez. Dr. Matías already did a nice introduction. I'm going to talk about how we find duplicate bugs at Oracle. Oracle is a huge company with almost 1,000 products. Each one of these products have problems, usually. And for Oracle, it's paramount to find duplicate bugs soon, so developers can solve these problems, these issues fast. This represents $1 million to Oracle if we find this fast and we solve this problem fast, given all the commitments Oracle has to his clients and the reputation Oracle holds with them. So we're going to talk about a bit about this project, but before we're going to do a bit of promotion about Oracle, what is my team, how we live there. So this is a safe harbor statement. It's like a requirement. Like everything I say here is just informative. It's not a promise of any product or anything like that. So it's just an informal talk about something like what we do there. So the outline of this presentation first is who we are, our life as part of Oracle. We're going to talk about a bit of our introduction to our project that is called Adaptive Bug Search. And then the technical part, the main part of this presentation is going to be the BERT model. That is a deep learning model very popular right now in natural language processing tests. And then a bit of how to join Oracle, some information if you are interested in being part of Oracle after you finish, or sometimes when you are in the last part of your project, you can go to Oracle 6 months, 1 year to do an internship there. So you start getting familiarized with how the industry works.
How do you define what is a duplicate bug?
A duplicate bug is a kind of similar problem that would solve
no, it's the same.
similar way.
Find two times the same bug.
Exactly. Well, it's sometimes not necessarily the same, but they have plenty of similarities.
Okay.
And at the end, this is at Oracle we have a database of bugs, and this database sometimes is like a taxonomy. Sometimes there are relations between these bugs, and these relations are labeled manually by developers.
Okay.
So somebody submitted a bug, and after a few weeks of iteration, they say, "Oh, this is some bug I saw before." Tag it as a duplicate. So we have a label data set in that sense. Like it's millions of bugs. I think in the last 10 years we might have like 30 million duplicate bugs. So we have a lot of data. That's one of the advantages of the industry sometimes. We have data, we have real data, but it comes with plenty of challenges too. So who we are? Well, we are called the Adaptive Bot Search Team, and we are four in Guadalajara. This guy is from Tec de Monterrey. He's an engineer from Tec de Monterrey. This is from SCOM. This guy is a master's degree from UNAM. And I'm here from Polytechnico, at the end of the PhD from Polytechnico. And this tall guy here is our boss in Guadalajara, that he was visiting in California. We are half in Zapopan, half in California. He's our local boss. And these ladies are engineers. They are one from Singapore. This lady is origin from China, but she was born in Pennsylvania. And this is our project manager. He's like an architect as well. He's quite important. Super cool guy. He's called Samir from India. From India again. So we are a very heterogeneous team. That's why it's so important to speak English, because there is no other way to communicate. So our life as part of Oracle, well, we regularly, at least once or twice a year, we have meetings. So sometimes we need to fly to California, and we have fun with the team. We do some team building activities and so on. We also do this kind of visit to plan our strategy more into detail, what we plan to do for this project, some deadlines and so on. But we also have plenty of fun there. And other things we try to do is to keep updated all the time. So during that visit, we also were able to attend a poster session at Stanford from students of engineering bachelor degree. From second, third year, they are already working. They are already working on the machine learning, and we attended most of these classes, like deep learning, applied machine learning, and natural language processing. The principal professors here. You can see this is Andrew Ng. He's quite popular. He's co-founder of Coursera, and is an eminence in this area of online courses. And this is Christopher Manning. Is also quite important in natural language processing. He's the author of Foundation of Statistical Natural Language Processing. That is a textbook very important for people doing natural language processing. And this is just a bit of promotion. Here is me with Andrew G, and kind of a groupie posing for pictures, kind of humiliating myself for a picture, but yeah, it was nice to meet him in person. This is Christopher Manning, and here we are in Stanford doing some sightseeing beside the poster session. This is one of the main points I see. It's quite important Mexico to update his program, because we see here students from second, third year of a bachelor degree. They are doing artificial intelligence already. They are doing deep learning. They're using the benchmark data set. They're using the latest models on deep learning. So I think we should try to keep up this pace, at least to get closer to them. I'm sure here in SEM.DEP they are really nice research, but we still need to grow more. Not just SEM.DEP. I'm sure SEM.DEP is top also as SIG, but we need more research and more relation between academy and industry. So this is, in August, I also attended the Oracle Machine Learning Summit. That's part of living at Oracle too. They invited me there to California again, and Oracle, all the teams at Oracle presents what they're doing machine learning regard, and all the infrastructure we have, all the challenges we have, where we are trying to go, our competitors, and so on. This picture is not the highlight of the summit, but it was nice to get a nice car for rental paid by Oracle, and doing some sightseeing as well. So that's a good part of being part of Oracle. They treat you well when you have to travel. They didn't pay for this, but just a mid-range car. But when we got there, they gave us a free upgrade. So what was nice. This is not the highlight of the summit, but it's nice. Now a bit of promotion. This is a kind of an idea how Oracle is going to be. Right now we are in Zapopan, and we are renting a building. We have 9 floors there, and we have another 2 buildings with 3 or 4 floors. We are around 1,400 employees, so we have a lot, and we don't fit there anymore. So Oracle is building a campus It's been built in ECampus since 2015, I think they got the land. And we are planning to move by the end of this year, so we're going to be there quite soon, and I'm going to show you a video. This is from 2016, so maybe next year if I come again I will show you how it looks for real. So, should be. Well, there is no sound, but it's just some relaxing music. It's going to be Oracle next year, basically. We're going to have our own building in one of the nicest places in Zapopan called Valle Real. I don't know if that's good or bad, because if you want to buy a place there, you have to pay several million pesos, basically. But at least to walk around is nice. We already selected our places in the building and everything. We have parties too, sometimes. This November 22nd, we're going to have a kick-off party, like all the employees goes there, and they show what is the strategy for next year. Well, that's the new campus we're going to have soon, so probably you should visit. It's going to be super cool. Now, this is the part of promotion. Now let's talk about a bit what we do there. So our project is adaptive bug search. The motivation is basically improve developer and tester productivity. I mean, if a tester found a duplicate, a bug, and it is duplicate, there is no need to submit a new bug. That's it, there's someone working already there. There are other kind of projects that is like help developers and support analysts identify or similar proven methods to triage similar issues. I mean, if there is a problem that is similar to the problem you have, you can see solutions they use to solve this problem. And also this point of contact is, we are also working in a project like you give me a bug, I can tell you automatically what is the developer that you need to assign this bug to be solved. There are plenty of engineers involved here right now doing all this work. There's some automation there too, but we are working to include more machine learning in this area as well. And then another project that is coming is recommend a patch to a customer. We have a lot of customers using Oracle database, but they have different versions of the database, and not all of them needs to have the same patch to solve a particular problem they might have. So we might recommend a particular patch for that particular customer to solve that particular bug they have. And with the new Oracle database, that is called the autonomous database, that almost everything we're talking about here needs to be done automatically. You won't need to have a database administrator to apply a patch and do all this process. Oracle will do this automatically. So that's the motivation. How we do find duplicate bugs. We have an input bug, is an engineer or a tester submit a bug. There is a report. Sometimes they have structured data, other times it comes with a lot of unstructured data like logs, traces. Imagine your database process is writing logs, whatever is happening is writing a lot of information. Sometimes you need to make a bit of sense that information, besides some structured data like what version of the database it was, what kind of product, what kind of subcomponent, and so on. So we have first that input bug. We have a database of bugs that is millions of problems, thousands of Oracle products we have there. We do a selection of candidates from that entire database, and then we extract features in both sides, and we do kind of pairwise similarity between this input bug and these possible candidates, and then we apply, in this case, logistic regression and get a report. This is like the model proposed like 5 years ago. We're trying to add more deep learning to get this part out, the extraction features, to do the pairwise similarity differently, and even in future stage to represent the bug as a vector representation, like you do with documents and so on, just to do similarity between the two vector representation of the bugs. And then you apply another layer of multi-layer perceptron or something like that, and you have a classifier to determine if it is duplicate or not. So this is the general schema of a product. But one important part is machine learning in real life. Sometimes not as we are used to in academia. In academia, sometimes you go online, you read some papers, and you see there is a benchmark data set. You download this data set, you create your model, and that's it. You test it, you do some cycles there, and you publish. However, in industry, it's a bit more complicated because sometimes you even have to get you need to get some legal review of the data you're going to use. You cannot use public data without asking the legal department if you can use this, or a data set provided by another company or another university. So then, after that legal review, you have raw data. You need to probably take just a subsample of this data and do the annotation part. That's one of the hardest parts, because sometimes in academia, if you're not creating your own data set, you're using an annotated data set already. We are in charge of doing all of that, to do the crowdsourcing, generating, of course, guidelines, how you do this annotation. And sometimes you need to compute certain statistics, like the agreement between annotators and so on. Probably some of you have been familiar, if you have done any data set in your life, there is a lot of things to follow. And in academia, well, it's something like that. And sometimes we will have the test data, but we also have a running time data that might be slightly different. So you might need to do some transfer learning between the two data sets, and so on. And sometimes you cannot represent your real problem exactly as is presented in real life. You need to come with an abstraction of this problem and get a data set for that problem, and so on. I mean, this is machine learning in real life. There is a lot of tasks involved that you are in charge of doing. Nobody is going to do it for you. So in academia, it's more collaboration with other universities, and there is more freedom also to use resources provided by other instances. So this is something you need to take into consideration when you are in industry. And another point is machine learning is not 100% of what we do at Oracle. If you want to incorporate a machine learning model into industry, you need to make it as part of a system, as part of a service, for instance. And doing that requires also a lot of effort, a lot of engineers that will do the configuration of the model, we do data collection that's sometimes related to machine learning, and also the feature extraction if you don't have any deep learning that do it for you, everything. And then the other thing related to the resources, you are like a training or you are running this in production, because Oracle, for instance, have a cloud computing like Amazon Web Services. Oracle also has its infrastructure, but you need a way to use this infrastructure. There's some challenges. It's not as easy as putting it in your personal computer. You need permissions. You need to make it efficient, so you don't spend. You don't waste Oracle resources, because this is at the end money for them. And then you need to analyze, you need the serving infrastructure, because, for instance, Oracle has the cloud infrastructure, and they have data centers in Frankfurt, they have data centers in London, in Dallas, in plenty of places, and our service needs to be working in those data centers specifically. There is not a central server, and they do this for safety reasons. You don't want to take client or customer data out of the data centers they are located. So you put your service in those data centers. So there are a lot of engineering challenges. I'm not in charge of that. I'm more in charge of the part of machine learning. But the rest of the team needs to do a lot of work as well. So this is also what is the machine learning part as part of the entire product we have. Luckily, I'm very glad with that. I'm in charge of this machine learning part that at the end is what I did, what I studied during my PhD. So now we're going to talk about one of the models we are experimenting with to do one of these pairwise similarity. To do, for instance, semantic similarity. You give me two sentences or two box objects, that is one data point of the box report, and how we compute similarity between these two particular features. we are going to talk about this BERT. This is not part of Oracle. This is a model proposed by Google a couple of years ago that has become like quite popular. So the technical part of this presentation is going to be focused on this model that is based on deep learning and is used a lot in natural language processing tasks. So the overview of this model is what BERT means, Bidirectional Encoder Representation from Transformer. There is a lot of terms here that might sound weird if you have never used NLP and deep learning. Transformer is another architecture we're going to talk about a bit about it. And this is encoder, but this transformer is encoder-decoder approach, model. And they only use encoder for this BERT. We're going to see it in more details later. What is BERT? Is a method of pre-training language representations. I don't know if people here is familiar with word embeddings, for instance, word-to-vec, where you have a word and you represent this word as a vector of numbers. And then you can use these vectors to do similarity computations. You can compute, if you have two vectors, you can compute Euclidean distance between them. You can compute the cosine of the angle between these two vectors. And you use these metrics as a degree of similarity between representations. So you need to represent words as vectors and then combine a set of words into a representation of a sentence or a paragraph. So this is what is called language representations, and right now they are the state of the art in every NLP, almost in every NLP task. To do machine translation, to do textual entailment, that means you have a sentence and you need to determine what is the next sentence to come. In language generation, you are giving a sentence and you need to generate something else, or you are giving a word and the computer needs to generate a sentence out of that input word. All of those models that are used currently are based right now in language representations, at least at the state of the art. And this BERT is one of the most popular ones right now. There are a lot of flavors that goes around it, but this was kind of like a groundbreaking one. There is also this unsupervised pre-training. We're going to talk about a bit what is that, and contextual word embeddings, task-oriented fine-tuning, and the state-of-the-art results on a wide array of NLP tasks. I'm going to describe a bit more each one of these. So unsupervised, usually when you have a classifier, you need label data. You need someone to tell you, given all these features, what is the class. If you're classifying tables, if you're classifying shares, you need somebody to have a few features and then tell you what class is that set of features. That's called supervised learning. You need to give them data that is already labeled. But the problem with labeled data is quite expensive. You need to gather people, tell them how to annotate them, see if they agree on the annotations, and it's quite expensive to get a large amount of data that is labeled. So this model is unsupervised, means you don't have label. And this is quite important because there is a lot of unlabeled data set in our environment. There is text everywhere without a proper label, but there is text. And what is called labels are the nature of this of the text itself. Text was written by humans, so they have some correlation between the context of a word is represented or is defined by the context, words in the same sentence. So it's unsupervised data where you have some meaning in that data. That is, a word is defined by its context. That's one of the principles of language at the end. So for this model, they use this kind of data that is unsupervised. For instance, they use the Wikipedia. You have access to Wikipedia. You can go and download a dump of the Wikipedia and train a model like this with that data. And they have some also like an online book data set, like digitalized books. So these are billions of texts that if you wanted to do a supervised learning, would be quite expensive to label all these data sets. So this model is trained on this kind of task. And the objective of this model, given this dataset, is the following. There are two. These predict only the masked words. They are given a sentence, and they will mask randomly a certain percentage of those words. For instance, I have this sentence, and I mask this, and I mask this, that belongs to store and garden. And then you will try your model to learn which words are here, like what is the most probable word that will go here and here. So you will learn some deep learning architecture, some neural network that will give each word of this a vector. But when you combine all these words and you try to predict this one here that are masked, you get a representation of these words also. Then you can do some like vector, like computation between them. That's one of the objectives you try to do. At the end is learn some representation for each one of the words you have in your vocabulary. The other task, the other objective they are trying to optimize at the end, because that's what a machine learning model does. You put an objective and you try to optimize that objective. You go like a loss function, you try to minimize this loss function. And this loss function is based on this objective, what you're trying to learn. And the second objective is two sentences given, and you try to tell if they are consecutive, if they are one after the other. So to do this, you can take two sentences from text, and then that's a positive instance, and to generate a negative instance, you take a sentence, and the second sentence is randomly selected, for instance. So all of this you can do easily with unlabeled datasets. Wikipedia, there is a lot of data, and the end, these deep learning models need a lot of data to learn representative models. So this is the objective of this, and what means being unsupervised. Now, contextual embeddings. I don't know if any here has any experience with word embeddings, word-to-vec, with natural language processing. Was what I was talking about. You have a word, like for instance bank, and you have a vector representation of that word, numbers. These numbers changed while you were training your neural network. At the end, these are weights of a neural network that change according to your training, using backpropagation. You do backpropagation, you change these numbers, you do another instance or another forward propagation, compute the loss, backpropagation, modify these weights and so on. So you learn a vectorial representation that are numbers related to a word. What means each dimension of this vector? Right now in neural networks really doesn't have any meaning, but the rationale of these models that you represent a word as dimensions, it started with some meaning. For instance, if you have a share and you extract features of that share, you can see the color, the material, the height, the width, several features, and each one of these features will be one of these weights. In a neural network, you put like a 300, and those 300 really don't have a meaning. At least a person cannot give you exact meaning, but you can correlate them to be features of the word, like you would do in a traditional classification where you have one object and you have features of that object. Now, there are models that are called word-to-vec, that was pretty famous as well, presented by Google, and GLOVE, that is global vectors, that used to get these representations for a word. But one of the problems that I have is these words have several meanings. Bank could be a bench, could be some like a sandbank, could be a financial institution, and you only have one single representation of this word, one vector representation of the word that will try to average the meaning of the three meaning of this word bank. That sometimes is a problem. So this BERT has its model is capable of give you different representation of this word bank depending on its context. We have different vectors for the word depending the context is appeared. Word-to-vec and GLOVE, they also there are two contexts related here. These models, all of them are trained on context. as well. You have a word, and they give in the context, they try to predict the word, but then you just get a fixed representation for that word. BERT is capable, is using context as well. It's given a sentence, you're taking context of the masked words. But then you can even change these vectors inside the word, inside the sentence you are trying to use for your particular problem. Well, this is a lot of natural language processing, but the idea is like this BERT may have different representation for a word that have several meanings. If you wanted to do this with this word to beg, you will have to represent this bank.1 for the meaning of bank, financial institution, bank.2 for the bank in this riverbank context. So this is one advantage of BERT as well. Task-oriented fine-tuning. So how can you use this model for a particular task, for a classifier, for instance, to compute similarity between two sentences? Because this was trained on an unsupervised data set. And now you want to apply this to a supervised data you have. For instance, email spam classification. Emails at the end, they are sentences, and then you have a class, spam, not spam. So you will try to represent this sentence as a vector, and then apply classifier. Traditional classifier could be logistic regression, could be multi-layer perception, neural network, and so on. And then you have a class. So what you do is you transform this to BERT, and you put a classifier on top of BERT, and you have a traditional classifier, where you are using its pre-trained data, because this was pre-trained on Wikipedia, so it has some representation for each word. You will try to combine them and have one single representation using BERT, and then you put another classifier that will use that representation and the labels you have to do the classification. So that's how you do kind of transfer learning. You use this pre-trained model and you apply for your particular task. You can do that, and they show how to do that in the code or in the papers as well. So this state-of-the-art wide range of NLP, where this BERT has been used, or have been used in these sentence level tasks. It means you have only one sentence and you need to give just one class. For instance, sentiment classification. This SST2 is a data set on sentiment classification, where you have to do binary classification. You are giving a movie review, and you need to tell them if it is a positive review or negative review. And everything that related to that kind of task, this model is quite good. And this is one of the benchmark data sets where they evaluated themselves and they got state-of-the-art results. There are sentence level tasks. There are also sentence per level tasks, like multi-natural language inference. There are some tasks like paraphrase identification, where you are given two sentences and you need to tell them if they have the same meaning. Or the other task, like this data set represents, is the textual entailment task. You are giving two sentences and you need to tell if the second sentence is a consequence of the first sentence. This model was used there in that kind of task and also gave state-of-the-art results. And there are also word-level tasks like a main entity recognition. You have a sentence and you need to tell what part of a speech is each word in that sentence. Like if it is a noun, if it is a verb, what time of the tense of the verb, and so on. Like pronoun. But there's that's part of a speech tagging that was used there too. And this is name entity recognition. Is more like you have a sentence and you need to tell if one part of that sentence represents an entity, like for instance, company name, a person's name, institution, and so on. Yeah, I confused it. This is a name entity recognition, but it was also used as part of a speech tagging. And there is a span level tasks, like this is a Stanford question answering dataset. Is a question answering dataset. You are giving a question and you are giving a paragraph, and you need to tell from which part of that paragraph answer that question. All of these datasets are like a benchmark. Every single person today doing NLP on these areas basically needs to evaluate on these data sets. It's like a benchmark in academia. And they, of course, achieve state-of-the-art results in all of these data sets. Now we're going to talk about what is the architecture of this BERT. So, what is the input representation? At the end, you need to represent the sentence as numbers, as vectors, something you can work with. So, for that, they compute something that they call word piece vocabulary. And BERT, in one of the pre-trained models they provide, you can download, they give you a fixed vocabulary of 30,000 words. One of the main problems other models had is this kind of language representation. They will train this, Google will train this for 2 months in a lot of computers nobody has except Google in a huge data set, and they will get some language model. Language model meaning representation of the words. But the problem they had a fixed data set, let's say 100,000 words, but sometimes for your particular task, that word was not found in the data set. So what you had to do was initialize the representation of that unknown word randomly, some normal distribution from 0.25 to minus 0.25, something like that. And that was a problem because for some particular tasks there were so many unknown words that this language model you were trying to use wasn't that good. So these people at Google, again, try to use this approach that is called word piece, where you will try to represent every single word in the universe in these 30K pieces. How they do that, for instance, they have banking here. If that word is not in the dataset, then we try to divide it into smaller components. Bank and the ending ing. So bank is the starting point of this word, and then the following part they put it with this ## ing. And in the worst case scenario, they will represent a word as single characters. Every character will be at the end of this vocabulary, every individual character. And in the worst case scenario, where you cannot divide this word into 2 or 3 components, it will be represented as individual characters, and that's it. But you will always have one representation for a word, and this character will have some vectorial representation that was learned in the original Wikipedia dataset. So that's basically, I think, in my opinion, was one of the main contributions of this model, using this kind of a tokenization. Then, each token is a sum of 3 embeddings. They have the token embedding, that is each one of these things in the vocabulary has a vector representation. At the beginning of the training part is randomly initialized. And then they have something they call segment embeddings, because you might have in your model 2 sentences if you are doing sentence per task. So you have 2 sentences that will be fed to the model at the same time. So you have this segment embedding that will tell you which part is the first sentence and which part is the second sentence. And then they have a position embedding. It's just like an enumeration of the tokens, how they appear, to take into account also the order of these tokens. Then they use the transformer architecture. I'm not going to talk too much about here because it's a lot of boxes that are probably difficult to see. But this is basically the architecture they are based on. It's a transformer that is basically based on the neural network, deep learning, that is like a self-attention. We're going to talk about a bit more what is the attention mechanism. And then some like a residual connection, normalization, then some feed-forward, like people that use neural network, just multi-layer perceptions, and so on. And there are a lot of things. They have an encoding part, this is a recorder part, and they stack plenty of these blocks on top of each other because that's what they like to do at Google. They have 300 million parameters that probably in academia you cannot do because you need like 16 TPUs training for 2 weeks. So that will cost you $200,000 just to do one round. So probably Google is the only one can do that for now, or Facebook too. So this is a very complex model, but it's basically this is a transformer model that is divided into an encoder and decoder. BERT only uses the encoder part. That's why it's called from encoders from transformer. So we're going to talk about a bit more about this encoder part only. That is, you have words, and these words have embeddings. That are the segment embedding and the word embeddings, and also you have the positional embedding of how these words appear. So you just sound them, you apply this self-attention mechanism, and then you pass this input, skipping the self-attention, and you do a summation between this original input with the output of self-attention, and you normalize. That's called in deep learning residual networks, and they are very useful in deep architecture where you have a lot of blocks, and you might have problems of vanishing gradient, because all of this is based on backpropagation and these derivatives. So when you have very long or very deep architecture, you have a problem called vanishing gradient or exploiting gradients. And these kind of connections, they are helpful to prevent that. This is very deep learning concepts. So basically this is the encoder, and then after this layer they put two linear projections that are basically multi-layer perceptions with the same size of output as input, and then they do also a residual connection here and so on, and they do this 6 times, one on top of the other. So it's a very, very complex model. If you see the pre-trained model, they have 340 million parameters they need to learn. So you need a huge architecture, a huge infrastructure to train this, because it's very time consuming. But now we're going to talk about a bit what is self-attention here, because it's one of the main also parts of this model. It's modeling based on a paper that is called All You Need is Attention. And we're going to talk about what is the motivation of attention, for instance. There are some models that are called sequence to sequence, some recurrent neural network that are called sequence to sequence. You are given a sequence and you need to generate the next sequence. Like for instance, machine translation. When you are translating, you are given an English sentence, and then you want to have a French sentence. There are some architectures, especially for this sequence of data, quite useful, that are called recurrent neural network, like sequence models that will give you a representation of a sentence, and given that representation will generate the next sentence. These RNNs are quite useful for this kind of data that is sequential, like text, which is sequential as well. But this model has a drawback. You get, for instance, an LSTM, a long short-term memory, and you are given these are input words. Imagine this is a sentence. This first word, second word, third word. In these models, you feed the first word, and you use the weight of the LSTM, and you give an output here, the state of this LSTM cell, and then you use this output and on the next word to generate another representation, and so on. And then you get at the end of the sentence, and you have a final representation for this sentence. Then, starting from there, you use another architecture, another LSTM, to generate the French sentence. The problem here is you are using just the last representation of the sentence, and you may have lose the dependencies between the words at the beginning. There are some long dependencies that LSTM still have some problems. LSTM was good for sequential data, but when there were too long dependency between words, like phrasal verbs with something in the middle, it had problems catching this dependency between words in long distances, because you are using just the last part and all this. So they propose the attention mechanism. The attention mechanism is you have the same encoder-decoder architecture, one LSTM, the other LSTM, but besides using the output of just one, you're going to use the output of every input feature you have, every word, passing through another architecture, another multi-layer perception. So this model here will take and give a probability of which word will influence the next word here. And then to generate the next word, you use the first word, and all of this with the probability of which word is more needed. So that's how attention works, and it's state-of-the-art results using this kind of architectures. So how it looks, for instance, in a machine learning, a machine translation task, you have an English sentence and you have a French sentence, and the attention mechanism, as it's giving probabilities to the inputs to generate the given outputs, you can visualize. That is one of the main problems also of deep learning, is difficult to visualize. Using attention, you can visualize which word of the English sentence have more probability to influence one word of the French sentence. In this case, as it is almost one-to-one translation, you can see that the lighter color are in the diagonal, meaning that noted is most probability for noted, is that the word that most influence this other word here. Does the attention mechanism what it does. So there are different flavors and forms of attention. This one I explained is the basic attention, but then with the papers, you need to read like 20 papers to get to the last point. Is from attention, there was generalized attention, there was a slightly different representation on how you do this part here, how you do this network here, this is a network. How you do that could be the basic, just a multilayer perceptron. There are other ways to represent, and they call that generalized attention. Then there is the self-attention. In this case, we have a sentence in English and we're trying to generate a sentence in French. But there are some tasks you need to attend the same sentence. You have an English sentence and you have to attend the same word. Like one word in the context is more influenced by other words, and so on. That kind of things. Instead of having two sentences, you have just one, and they apply attention. That is called self-attention. And then there is the multi-head attention, that is applying the self-attention several times in several heads, and then concatenating them. That's multi-head attention. And then, after all of that, you get the transformer. That is the one used in this BERT model. So this is the transformer at the end. This here is called self-attention, but it's also multi-head attention when you apply these several times. That is what they do. So an abstract architecture of how you use this model is, for instance, you have a task and you have like a masked sentence, the first sentence you saw, and you mask some tokens there. Then you have another sentence, you mask some tokens there, and you will try to learn the representation for those masked tokens. You are trying to predict those tokens, and then the output is like this. You have one output for each input token. When you want to use a classifier, you just put a multilayer perceptron here. When you want to do like a name entity recognition, you use every single output for every single input. If you want to use contextual word embeddings, you also use every output of every input, and so on. This is the way you train. This is the way you use this pre-trained model into a particular task you are interested in. Use this. For instance, you want to do question answering. You have a question here, and you have the paragraph here. You need to take the answer from, and then you present it all together, concatenated. You feed this to BERT, and you will have some representation when you use the last m outputs of that representation. And so it's quite simple to use. My recommendation, if you want to learn this, is better to study the code. Then it's going to be more complicated. But that way you will see how it really works. Because there is a huge difference between theory, what you see in the paper, and what you see in the code. There are some tricks, how they want to do the word embeddings, how to do the layers of attention. There are a lot of tricks how to do that, with reshaping a matrix, representing the matrix concatenated, and then breaking it apart again, and so on. It's quite useful to do the kind of study, to study the code that will tell you exactly how the paper is working. You will understand the concept of the paper. And how to use is, first, the simplest way is to load one of the pre-trained embeddings Google provides. You can go to the GitHub repository and there are going to be links to load these kind of models. And there are different models. There are something they call BERT large. There are more layers, more parameters to learn in the network. But they have like 24 layers. They have 124 hidden size each one of these layers. There are 16 attention heads. And in total you have like 340 million parameters in your neural network. And you have cases like when you use case or non-case, I mean you use words or lowercase or word keeping the capital letters and so on. So they have different versions, case and non-case. There is something here called word masking. Remember when we do this word piece tokenization where you break down one word that is not in the vocabulary into smaller components that are in the vocabulary. The first masking they were doing, they were just masking 15% of these tokens, but sometimes you will mask one part of the word and the other part not. In a word that was broken into 3 parts, for instance, you may end up masking just one word. In the last approach, in the last model they presented here, they put an approach that you cannot do that. You will just mask the 3 parts of a given word. This is just technical part of these models they do. So if you want to use this model first, you do load one of these pre-trained models they have. They receive one for Chinese. And then you see what is your task, and you just represent your input in this way. If you have, for instance, in our case, we are doing similarity between textual part of 2 bug reports, 2 sentences, like the subject of 2 bugs. We just put one subject here, the other subject here, and then you have the multi-layer perceptron in the first token of the sentence. That is this CLS is a special token you put at the beginning of the sequence representation. And then you just put the multi-layer perceptron here and you get the classifier. You train this in your particular dataset and everybody happy. That's the easy way to use. Basically, in the code, when you have to code this, you basically need to create a class that will read your dataset and represent it in the way they want it to be. And it's not difficult. You can, in the code they provide, there are examples for single sentence tasks, for pair of sentence tasks like the one we have. You can reuse this code and change it to your particular dataset. This is quite simple in that regard. And it's basically that what you need to do to use it. And there are different, like a single sentence task, question answering tasks, and so on. It's simple to use, but it's very good exercise to know how it works deep inside. If you want to work on this and then you want to propose a simpler approach of this BERT, that there are already a lot of papers on simpler approach. There is another model from Facebook that is called Roberta. They just put Roberta, and they are based on this. So BERT's Google, Facebook created their own using this model, but it made it simpler and more optimized. Like you can do training faster. And there are a lot of work on this. I mean, NVIDIA is working hard to make their GPUs able to run this model faster, for instance, and things like that. So this is a lot of effort here. You will see a lot of companies putting a lot of money and effort in this area, and we are using it too. So some reference, these are only a few because there are thousands of references on this, but the main one is this, BERT, pre-training bidirectional transformer for language understanding. This is the main paper of BERT. But this model is based on the transformer. The transformer is introduced in this paper as attention is all you need. These two, Google, both of them, and there is some tutorials that will teach you how it works in a simpler way because it's very complex. So you need to read this paper 10 times, to watch this tutorial 10 times, then to go to the code, see this code 10 times, and then you might have a better understanding how it works because it's very long. This is also the main repository of BERT for TensorFlow, that is Google tools for deep learning. So here this code is in TensorFlow, but here you will also find some links to some implementation in PyTorch, for instance. And these, at the end, they are more like tutorials how this model works. If any of you is interested in NLP and deep learning, you will find this quite useful. And if you are doing thesis on that, you will have to add this to your state-of-the-art studies for sure. So, how to join Oracle? Well, what we're looking at Oracle is like a strong coding. There's some requirement that sometimes academia lacks a bit. We need people who knows how to code, because you cannot use plenty of these things and use 10 Python for loops instead of doing a well-vectorized model using NumPy, for instance, that does everything in just one magic multiplication. So we need people with strong coding skills foremost, because we need to code this in an efficient manner. This is to be running in a service that is easily scaled and that works fast, and people who come after you might understand. And also ability to solve very difficult problems. Myself, I'm working on these deep learning approaches, but I'm also working on traditional machine learning using logistic regression, traditional natural language processing using TF-IDF and back-of-word approaches. We're using also CNNs and more deep learning. But sometimes I've been using lately, for instance, like a longest common subsequence, that is a traditional computer science algorithm to find two sequences that repeat in two sequence of elements. So sometimes you need the ability to solve very difficult problems, and when we are hiring and doing interviews, we're going to ask simple problems like that to see how well you do solving problems, how your brain works. Well, some technical degrees could be computer science, electrical engineering, physics, math, something like that. It's always welcome. For sure, is fluent written and spoken English. One of the advantages of Oracle here in Mexico is Oracle has 3 development centers. There is one in California, there is one in India, and there is one in Mexico. There are only 3 developer centers. So we do new things at Oracle Guadalajara, but usually it's not just a team in Guadalajara, it's half the team here, half the team in California, sometimes half the team in India. So you have to speak English for sure. And these strong grades or experience, sometimes you lack a bit in school, but you might have some experience or you try to study more. Of course, strong grades sometimes is good to have. And more proactive, goal-oriented, focus, who want to become specialists, because you need to learn constantly. This BERT model I didn't know when I left, I just heard about it when I finished my PhD. So I had to study all this all the time. You need to attend conferences, you need to attend some seminars at Oracle. Oracle sometimes also pays for Coursera courses if you need to take, like this Andrew NG Deep Learning course, and so on. And at the end, what we want is employees. We don't have outsourcing or anything. We want employees. We will have full benefit, like health insurance, full salary. We will be based in our campus that is going to be quite new. Next year going to be there. So I don't know if Dulce wants to add something. He's from Human Resources, so she will know.
So thank you very much, Miguel. Yes, my name is Dulce. I'm part of the recruitment and selection team. Actually, this is like the most important qualifications that we are looking for. But besides that, we really want to have people that enjoy coding. We want to find people that feel passionate about everything that's related to programming, because we want for you to pursue and keep doing the things that you enjoy doing at most. So this is the most important qualifications. One of the things, like Miguel said, that I really loved about Oracle is since the beginning we can see that you are a very talented person. Oracle really encourages you to do new things, to try new things. You can take some courses. The most of our benefits are beyond law, and it is like a very competitive related to the market. So if you are interested in coding or in programming languages, doesn't really matter which one. If you like Java or Python, we really encourage you to apply to our positions. And if you are willing to live in Guadalajara, you already saw the campus, it's pretty great. We're moving, I think it's on the next year, right?
By the end of this, but there's always some delays because government permits and so on. But they say the latest by the end of the next year, because the next month, at least my floor is already rented to another company. So we have to could go away, work from home or something, but next month, December, is already rented to another company. So next year we have to be there, or for we have to, well, I will go work from home from Cancun or something like that.
Yeah.
That they allowed me to do sometimes.
So this is like the ideal scenario, but if you are currently studying, the most important thing is that you are interested in joining Oracle. On the other hand, we can work on that, or we can review in which kind of position your profile works best. So if you're interested, you can always feel free to reach me out or Miguel, but this is like the most important qualifications for the positions that we are hiring.
Well, that's it. There's some point of contacts if you want to contact one of the recruiting team at the end. And these, if you want to take a test and then be interviewed by someone, you can go to this link and apply. You will get some basic computer science problems, and then you might be interviewed. There are opportunities for people who are in the last semesters to do internships as part of Oracle. We have some talks with UNAM as well, with the EMAs, to promote them to go and do a project at Oracle, and they will do their graduation with this project. So instead of a thesis, they will do a project at Oracle. And they will have to write just a thesis now of 20 pages instead of an entire full manuscript. So, I mean, actually, in my case, I did an internship at Oracle while I was doing my PhD. I was in the second year of my PhD, and I did an internship for 6 months. And that's why I got the job. I mean, I didn't even apply for an interview after the internship. 2 years later, I finished my PhD, and Eric Peterson called me, that is the managing director of Oracle Mexico, in Zapopan. He called me, what are you doing when you finish? You want to come? Yes, and I end up with the same team at the end, with the same project I worked 4 years ago. So I encourage you sometimes having a real life experience help you to see how the industry behaves, and give you good experience how to work machine learning with the real world data. So basically, I don't know if you take a picture of it, but that's it. So I will put this back.
Miren, yo les propongo, si quieren, hay como dos componentes, una la parte de investigación y otra la parte más de interés y reclutamiento en la empresa. Si gustan, la primera parte, digamos un par de preguntas con una exposición larga, más larga de la que usualmente tenemos. Si gustan, dedicamos algunas preguntas a la parte más de investigación, y en una siguiente parte, pues ya los interesados ya lo pueden hacer ya sea en corto o también de manera abierta, ¿no? Entonces, quieren ahorita en esta primera parte preguntas de investigación, en español, en inglés, como prefieran. Entonces, pues adelante.
No sé si tengo una. En español.
¿Cómo qué?
Mira, me llama mucho la atención que el bug lo busquen en los reportes del bug y no en el código, porque el lenguaje de programación pues es algo más simple, es muy sencillo, los lenguajes de programación. Entonces, que aplique las técnicas al reporte, también a los archivos de log del sistema. Entonces, ¿qué indica? Que no hay una relación 1 a 1 entre el código y el problema. Puede producirte distintos códigos el mismo problema.
Eso es complicado de responder porque the database is a huge system, has like thousands of lines of code, and has a lot of configurations. So there might be a lot of different configurations that may have caused the problem. We do take into account, for instance, the stack trace. When something breaks, give you a trace of what broke in which function, then the function that called that function, and so on. So in that sense, we are using the code, and we have some other approach where we try to correlate a file of traces. I mean, this code is generating traces in some file, and this file we analyze it and try to correlate this to part of code. But I mean, the code is also changing a lot, so sometimes it's not the same line number. It's very complicated. And I mean, this one bug, if you relate it to the database, and depending on how much traces that you are generating, you might have gigabytes of information, gigabytes of traces with memory dumps, with more like a ensembler in assembly, assembly code, because this code is transformed to assembly at some point, and in one of these traces sometimes they have assembly code, so you need to do a lot of manual inspection of this assembly code, looks like this part of the code. There are some people that does that manually. Do it automatically is a big challenge. That's a problem in the industry. You have to have a lot of data and make sense of that data, make a subset of that data, so do some parsers that will, for instance, remove the memory dumps that for some particular case might be useful, but most of the time might not be useful because it's not generic. The memory dump is just for a particular computer where it was run. So it's very complicated, and the system of Oracle, the database is huge. So yes, it's quite important to look this correlation between the bug and the code, because at the end the code is the one that generated the bug. So we use part of it. We use the stack trace. This stack trace is when you break something and say this function, this file, then the other function, this file, the other function, this file. But you might have Java code, C++ code, C code, Python code, Perl code. Is a lot. But I mean, in the bug report, there is that information as well. There is the information about the version of the database, the stack trace, which traces are generated, and so on.
And I have a second question. Is how you are sure that the models, I think these all generated automatically, how these automatically models are correct models?
Evaluated, yes. Well, we have a feedback from the developers. At the end, this is something that we're evaluating, for instance, 2-3 months. I mean, we have our data set, we split our data set, like a training, cross-validation, and test. But in real life, when we are using these models, after 2 months, you review the predictions you did 2 months before, and you see if this bug were labeled manually by an engineer as a duplicate. So that's the feedback you get. That's the feedback you get, like you did the prediction right. You see that 1, 2, 3 months later.
So
after
you're
the box
working in
closed.
parallel with the automatical system, and you continue.
Well, we generate data set. At some point, we generate a model, a stateful model, and then we use this model for several months, and then sometimes we might retrain this model. Okay. It's not this. I forgot the name. This you are constantly changing the model.
Okay.
This, I'm blocked now. But yeah, we just generate a model, and after a few months we generate a new model.
Okay.
It's not like what is the name of that? This kind of models you are training constantly all the time. Live. There's one name for that, but I forgot. No, we generate the model before. And then we evaluate like that with that kind of feedback. We do some prediction, and after a few months after the bug is closed, we see if the bug was labeled duplicate, then you get feedback there. And sometimes you get more informal feedback from developer. Oh yeah, this tool is good, it helped me fix this problem, and so on. But the way to evaluate the model is that way. Because at the end, this is a real problem. So after sometimes a month, you will see how it was fixed and it was labeled duplicate or not. So you will get this feedback.
¿Alguna otra pregunta? ¿Comentario? Yo quisiera preguntarte, es decir, entiendo que el trabajo que tienes y todo tu equipo es identificar los problemas similares que se puedan presentar. Pero entonces, digamos, aquí pareciera que esto es el cuento de nunca acabar. Digamos, como que es un problema que está siempre presente y quizá, no lo sé, y esa es parte de la pregunta, si hay, digamos, algunos problemas como frecuentes que se presentan y que los tienen bien identificados, y que en ese sentido, al tenerlos bien identificados, fácilmente ustedes pueden decir: este problema es similar o el mismo que se nos presentó antes en tal lugar, y a partir de ahí pues agilizan la solución, el que ese problema pueda tratarse de una manera eficiente. Pero pareciera, y entonces, bueno, pues la disminución en costos, que es una cosa fundamental, disminuye. Pero pareciera que es como, bueno, ese lo tenemos caracterizado, pero claro, habiendo tantos usuarios sobre tantos dominios en el mundo, como que es algo que siempre va a haber. Entonces, digamos, ¿es cierta mi apreciación? ¿O en realidad sí hay una tendencia a disminuir, aunque sea de manera, digamos, asintótica, los problemas que tienen, y por lo tanto también el costo pues disminuye asintóticamente, o en realidad el costo, el gasto que tiene que asumir Oracle por los problemas que se presentan, más o menos se mantiene siempre el mismo?
That's a very tough question, especially the part of like expenses. Because what I get for that question is that one point would be that you have plenty of problems. Now you get the model that tells you when it's duplicate, so you don't report a bug. So you will decrease the number of duplicate bug reported, because people already know this is a duplicate, so they don't submit it anymore. Sometimes you can do that. Before submitting the bug, you use the model, and it tells you if it is duplicate, then you don't submit it. So the number of duplicate bugs will go down. But another problem is Oracle is constantly creating new products. So when you create a new product, there's a lot of problems that will arise at the beginning. So using this model will save you a lot of time and money. But getting this correlation, like the price goes down, is difficult because there are plenty of factors like the new update, the new product. And also this model is sometimes trained with data of these different products. That's related a lot in the way we create the data set to train our model. How you create it. That's a really, really complex part, because the duplicate bugs you have already in the data set. In the database of bugs, you have them already labeled. But how you create the negative pair of bugs that they are not duplicate, and you learn some meaningful representation from there, is quite challenging. So to get that representation of I don't know if you mean the cost or the number of bugs, or the number of problems you're going to get once you use this model. I don't know exactly if you meant that.
No, yo creo que efectivamente sí me contestas lo que, digamos, mi pregunta. Es decir, porque tú me dices, bueno, si tenemos una aplicación, ya lo caracterizamos los errores que tiene, y entonces ya sabemos cómo disminuirlo, incluso los usuarios ya saben, ¿no? Que es el error tal, y entonces ya ni siquiera lo reportan, lo resuelven de manera local. Pero claro, ustedes desarrollan nuevas aplicaciones para dominios específicos, que siempre surgirán nuevos, y entonces ahí, claro, el problema puede presentarse, y claro, ahí la identificación es otra vez volver a la similitud. Ahora, el costo que se les puede generar, vale, claro, es decir, es tanto a nivel computacional, a nivel de lo que tú me decías, que a veces tiene que ver con la configuración correcta o no que haya hecho el usuario del equipo, de la nueva aplicación. Eso también tiene una curva de aprendizaje. Entonces supongo que hay un montón de factores.
There are a lot of things involved, but what we're trying to do is precisely to tackle that. Once a new product comes or a new update comes, the model can be retrained and deployed. It's like you don't need to spend the same time or money to train engineers to detect this. The model you train in the last 10 years data, for instance, and it will learn, will probably detect the new problems. Of course, if there are other problems already in the data set duplicated, labeled as duplicate, then how you can learn that? That's very tricky. Or this is not the only tool Oracle uses. Oracle uses a lot of deterministic approaches as well, or some probabilistic approaches as well, to get a set of symptoms of a problem and give you a possible solution or possible developer to solve this. I mean, Oracle has a lot of tools to try to triage a bug. how to solve the bug. So it's not just this model.
Y más o menos tienen caracterizado, digamos, como cuál es la probabilidad de surgimiento de error que tenga con una nueva herramienta que ustedes, con un nuevo producto que ustedes desarrollen. Más o menos ya dicen, bueno, ya sabemos que para un nuevo producto nosotros se nos van a presentar esta cantidad de demandas, de problemas que pueda tener el producto. Supongo que sí lo tendrán caracterizado.
Al menos yo no tengo esa información. Tal vez mi jefe, que lleva ya como 5 o 6 años trabajando ahí, tenga más idea de cómo ha ido evolucionando el problema, las probabilidades, el feedback de los usuarios y les ha ayudado a una nueva aplicación o no. Well, I don't know if everybody speaks Spanish.
Or English.
Okay, well, my manager had like 5-6 years working there, so he had more information how the learning curve has been going when new products arrived, how we managed to characterize these problems. Some products might be 60, 70, 80% accuracy to find the duplicate or not. It's very interesting to do this kind of a statistical analysis, but I don't have it, at least not in my case. I've been there just for 1 year. What we have seen is that in the new product, in the autonomous database, there are a lot of duplicate things happening. I don't know the percentages, but there are a lot, because a lot of products are submitted automatically. So if you have an autonomous database using France or another in London, they are submitting a lot of problems. So it could be like a 50% of the bugs. I remember that, like around 50% of the bugs submitted for the autonomous database are duplicate. So that's a huge cost for a company.
O sea, yo creo que matemáticamente pudiera haber una caracterización para los que hacen verificación formal.
Seguramente.
Probablemente, y claro, pero luego hay distintos contextos, distintos dominios, distintos problemas específicos, que esos ya son los que generan los problemas puntuales.
We need more scientists to do this kind of characterizations, for sure. I'm the only one with PhD here doing this kind of stories in this particular team, so it's a lot of work. Yeah,
only one PhD?
Yes, in this team. But of course, this is something like the better the product gets, the more products we cover, because we don't cover every product at Oracle, the more money we get, more budget we have to hire more professionals. In our team, we are searching for another machine learning engineer or scientist, like a master PhD, and we're also searching for engineers to do integration, more programming. I mean, at the end, we need people who knows how to program well, but we are looking for that. Here in Mexico, I think we hired just a new machine learning scientist in the US as well for our team to do some question answering and something like that.
Okay.
But yeah, these are analysis, like formal analysis, mathematical analysis, at least I don't have it. I mean, I go